and welcome to today's webinar on anomaly detection. My name is Sanjay Sarathi, and I run the marketing organization here at Sumo Logic. And I'm really excited to have my colleague, our co-founder and VP of Engineering, Kumar Saurabh, with who's going to be presenting both the vision and actually showing you anomaly detection. Before we get started, I just want to go through a couple of housekeeping items. First, this webinar will be recorded, and so if you have to drop off early or if you have colleagues who aren't able to join us today, we'll be sending out a link to the recording after the webinar is completed. So we're going to leave plenty of time for questions and answers. So as Kumar goes through his slides on the demo, feel free to ask questions in the Q&A box that you see in the WebEx panel that's in front of you. And I'll take all the questions and relay them back to Kumar, and we'll do our best to answer all of those that come in. And obviously, if you've got additional questions after the fact, don't hesitate to reach out to any of us. My email address is sanjay, S-A-N-J-A-Y, @sumologic.com. So with that, I'm really excited. This is a topic that I know the whole team here at Sumo Logic is quite passionate about, and the anomaly detection capabilities have been a couple of years in development. And when we launched it last month, really it's a furthering of our vision of enabling enterprises to uncover all the events in their machine data, both known and unknown. And Kumar will certainly talk about that in his presentation demo. And I think the second point that's really interesting, certainly to me, when I started to see the data is really how it integrates both machine learning with human interaction. And our belief and hypothesis is the best analytics really need to combine both of them together. And hopefully when Kumar walks through his presentation, you'll get a feel and a sense for that. With that said, I'd like to turn the phone over to Kumar and have him walk through a set of slides as well as a demo.
Perfect. Thanks, Sanjay. So, thank you all for joining me in this presentation, in this webinar. And, first of all, those who are new to Sumo Logic, I'd just take a minute or so and give you a quick background on the company. We were founded in 2010, and Christian and I both started the company in early 2010, and it's amazing that it has been about 3.5 years into that journey. We're lucky enough to be backed by some of the leading investors like Greylock, Axel Partners, Arturo Hill Ventures, and Christian and a lot of the team here, we have worked in the enterprise space. Christian and I particularly have spent in last 10, 12 years in the field of log management, security event management, log analytics. As the company back in 2012, and since we have seen a tremendous amount of traction, we have more than 150, somewhere close to 200 customers so far, and we've observed a lot of the same use cases across a different variety of customers. And so what I'll do now is I'll dive into how I see the IT analytics landscape today, right? So when either you're doing IT operations, application management, or security event management, in all of these areas, there are events, there are situations that you have seen before. These are known scenarios that, it's not automated, it's not proactive, but maybe you have a set of, playbooks, maybe you have a set of incidents and history behind those incidents, and you can refer to those when those new situations arrive. And so what I'm showing on this slide is basically two dimensions on which analytics can be very helpful. Is one in handling known scenarios versus those that are more effective at handling unknown scenarios. And the other dimension is, are you in a reactive mode or are you in a proactive mode? So these tools, playbooks, knowledge base articles, help desk tools, are the things that that help you react to things that are already known, that you have seen before. The next category of items are when you run into an unexpected scenario, an unexpected error. And those are the scenarios where, the ability to index and search all of IT data becomes a really powerful tool. And we see this with our users all the time. Whenever a new error happens, there's some slowdown in application performance. More often than not, the clues are in the log data. And it's immensely useful once the collection is set up to dive into all of that log data and within a minute or two be able to find the answer, be able to identify the root cause, or be able to identify even sometimes a security attack in progress, those kind of things, or do security forensics for events that might have happened a long time ago. But the part there is you're still in a reactive mode. Something bad has already happened. Events, maybe a security attack has already happened. Maybe someone already moved a bunch of sensitive data out of the correct IT network, or maybe the application performance has already gone down. So search is a tremendous tool to get better at those in future. But people have asked us again and again, how can we be much more proactive about these? And once you discover something, and once you know what the root cause was, maybe how to prevent it, or maybe you figure out what are leading indicators of those things, you can actually get proactive. You can get proactive by monitoring for those events, by alerting on those events, or using dashboard kind of technologies to look at what's going on in real time. But again, you're being proactive, but it's still looking for things that you already know you are looking for. That leaves a big subset of things open, is the category of things that you don't even know you needed to look for. IT landscape, IT data landscape is so fast-paced. There are literally hundreds of devices out there. Many guys who are pushing out or running business-critical applications, sometimes they get updated every week, every few days, every month. Every time that happens, log data changes a bit. And every time a new kind of device comes out or a new vulnerability gets covered out in the open, you will start seeing new kind of attacks. So to stay ahead of the curve by manually doing all of this work, by manually trying to figure out what are all the things that you need to look at, is just a humongous problem. It's a Herculean task to be able to do that. And that's where we have always felt that we need a much more predictive and a proactive approach to things, where this is all the data that the machines are generating, and a small IT infrastructure can easily generate tens and hundreds of gigabytes and terabytes of log data a day, and for a team of analysts to be able to figure out all that's going in that data is just impossible. We need, what we have felt that there has been a need, and the need has grown tremendously over last 5-6 years, I would say, is the ability for the machine intelligence to kick in and highlight what are the interesting nuggets of data, of events up to the user, and let the human analyst augment those findings with more analysis. And that's what essentially we have done with the launch of Anomaly detection. So what we have done is, when we launched the company back in 2012, we already had a very scalable analytics platform. You can index and search and query literally terabytes of log data a day. And in the company, one of the key capabilities that we have is the ability to turn this log data into signatures. And why is that important? The reason is, and I'll demo this a bit later, when I into our own deployment, we are running about 300 servers or so in production. We generate about half a terabyte of log data. Very small company, and very early, very young in our journey, and yet we generate much more data. And just till a few years ago, only the very large companies were generating. And B, when I look for errors, I'll typically get back in an hour maybe 100,000 log lines. Some of them are just information log lines, but they have the word error in it. Maybe it's an error metric that we are tracking and so on. So what the signature library allows us to do is, no matter what the source of data is, as long as it's generated by some printf statement somewhere in the code, in firmware, in an application, in an operating system, we can take those logs that we see and we can infer what was a printf statement that have generated that log. And the ability to cluster and group all of the log data, literally sometimes hundreds of thousands of log data, back into maybe 10, 20, 100 signatures, very effective, because what it allows people to do is they can review the entirety of the log data literally in seconds and minutes and dive into things that are really interesting. So that was something that we had in 2012. And we also had the ability to visualize all of the data. And maybe you want to plot how many errors I'm getting every hour. And you want to build a dashboard of it so that you can monitor it in real time. Or maybe you want to schedule it so if the error goes above a certain threshold, you get alerted. Again, all of these capabilities are manual and allow you to deal with something that has already happened and find the root cause. What was missing is, how do we become proactive about these things? And to that end, what we have built in last 12 months or so, a data mining module into the product. And what the data mining module does, it builds on top of the log reduce, the capability that we can turn logs into signatures, and we do that without users having to write a single rule. And on top of that, we have added the ability for the analysts, for the human users, to provide feedback, because machines can only look at the data that is in logs. There's a lot of semantics and a lot of business context that sits in our heads, and we can put that into the system to make the system smarter over time. So that's what anomaly detection does, and I'll dive into some of the key attributes of anomaly detection that we have built in. And first and foremost is, this technology needs to be able to deal with the log volumes that you get today. No longer are you just analyzing 10 gig of data, 100 gig of data. So we literally need to be able to use the distributed computing infrastructure that we have, the cloud that we run on top of. We use that to distribute this processing over multiple nodes. And what that allows us to do is we can run this sophisticated analytics in real time at a terabyte a day scale. This part is and we have seen several times in last 24 months, is that log data keeps on changing. The log formats keep on changing, and we can't predict all kinds of log formats will ingest. So log reduce technology is a key piece of this puzzle, the key piece of the solution. And what it allows us to do is, without you having to write parsers and all of this and tell us what the syntax of the data means, the system is by itself able to decipher that and figure out whether the logs are of the same type or of different types. So you can, even today, and in the past, what we have seen is people had a choice. They can do more sophisticated analytics, but they can only get those answers 3 hours later, sometimes 12 hours or 24 hours later. For operations and security use cases and for application support use cases, those kind of turnaround times are just not acceptable. Don't work. If the site is down or the application performance is slow, or you suspect you are under a security attack, you need that intelligence. You need those insights in seconds and minutes, not in hours and days. So one part that we have done is we have built the entire anomaly detection engine on top of our CQ engine, our continuous query engine. This engine basically is like a standing query, and the data is fed through it. And every few seconds, it will generate results. So it's not a batch processing system, but it's a real-time online data processing system. And anomaly detection is built right on top of that. Now, the other piece that is very critical to this is, I mean, one of the main use cases for using a solution like ours is the ability to see log data from different applications, from different layers of the stack, all in one place, and be able to correlate different pieces of data together to drive higher level signals. And that is what we do right now. So anomaly detection doesn't just look at one type of data. It looks at, different kind of data, and what it tries to do is it tries to notice, hey, the logging failures went up a lot. At the same time, I'm seeing a lot of firewall connections getting dropped. And it will be able to kind of bring those two pieces of data in the same place and highlight those for the end user. I think that's the key attribute, because you can look in few known places, but you might often miss signals, or you might often miss insights. You need intelligence, you need signals from different layers of the stack. And I think that's one of the things that makes anomaly detection so much more powerful, because it has the ability to look across all the different types of log data. And the last piece that I alluded to a bit earlier is we did not stop at whatever data mining we can do and present those insights, those analysis as gospel to the end user, or as like known facts to the end user. What the system does is it looks at literally hundreds of gigabytes of log data that you might have sent in last 24 hours, and it says, hey, something happened at 9:30 last night that looks really suspicious. It provides evidence of why it thinks that looks suspicious, and demo that just in a bit. But it allows the end users to look at that and do further analysis, and you might be able to figure out, hey, I know maybe we pushed some new code in there, or maybe one of the servers was down, but you understand that that's not a very harmful event, and you can label it as a low priority event, and you can say, you can give it a name, server went down, or you can basically just say, hey, we are running a cron job, and that generates this kind of deviation from the normal behavior. On the other hand, if there is a real attack going on, or if there's a real application failure that's going on that you've never even seen before, you were never even watching out for, right? It will be able to hide those to you, and it makes you more proactive. You might actually react to things before the error has propagated. If it's a security attack, it reduces your mean time to identify, quite honestly, because you'd otherwise have waited for something to go horribly bad before starting to look at it and before starting to remediate it. So that all of that capability comes together in this functionality that right now we are in a beta phase that we just launched for anomaly detection. Now I'm going to dive one level deeper and kind of right before the demo. We are literally one slide away from the demo, so don't want you guys to hold it up. But what I wanted to do is kind of give you a detailed view on the components, on the stages of the workflow that we have, how anomaly detection actually works. In order for anomaly detection to work, you have to just point at a set of data. You can point it to all the data, you can point it to maybe your firewall data, or if you have a cluster of application, that's a cluster of nodes that is a component within your application, you can point it to that. And then all of the log data gets fed into our log reduce engine. And what comes out of that, we have a global signature library, so as the data is coming through, we are identifying what kind of data it is. Use the library that we have built over time by looking at your log data. So there is no human step required to do this log reduce. It happens in the background. And out of that, later on, a follow-up stage to that is the anomaly detection engine. The anomaly detection engine is doing two things in the background at the same time. One is it's building a baseline of what your log data looks like. So you almost always see some errors. Maybe you see a lot of information logs of this particular type, and so on and so forth. So over time, it starts building a baseline of what is application behavior, last 6 hours, last 24 hours, and so on. And then in another thread, what it does, it looks at last 5 minutes of data and says, does this data look like I would expect based on the baseline that I have been building? And whenever there is a significant deviation between baseline and what you just saw in last 5 minutes, it calls that an anomaly. It's just an anomaly. The system doesn't know what it means. It doesn't know the semantics of it. It knows that it's an important signal for someone to look at, right? And so we present all those events as unknown events because we really don't quite yet know what those mean. Now, analyst or a user can look at those unknown events and look at the details of why that anomaly happened and can review it and can provide signals. Sorry about that. Okay. So human analysts, the users, can actually look at an unknown event, figure out what it really means, and turn an anomaly into an event. We have an event database to which we add, we'll call these known events, because you have taken an anomaly, done the analysis, figured out what it is, it's a known event. And we have the event database. What we also start doing that as you go forward, look at other events that anomaly detection is generating or had generated in the past, and we'll compare it to the event database. And whenever we find two very similar events, that's the pattern matching part of it. One, we can detect unknown events, anomalies. On the other hand, once you tell the system what those events mean, we can also match the new events that come in and classify those as known events or unknown events. When people sign up for beta or start using this particular functionality, they start with a lot of unknown events. And as they analyze the unknown events and classify them, over time, the percentage of known events goes higher and the unknown events become more and more rare. And at some point, it's down to a few that are really suspicious that you have never seen before, and those are something worth chasing them down. So with that, I'll pause here and do a quick demo of all of this works. What here is our product window, and I will log into our system right now. So this is our, the service UI, and one of the places where I spend personally most of my time is the search window, right? And the search window is very effective for two kinds of things. One is if I'm looking for something, if I'm doing some forensics, either for operational use cases or application support mostly, I can find things that I'm looking for, right? It's mostly in the reactive phase. What I can also do with searches is I can turn things that I get into visualizations or trends, and I can see all of them. So, for example, I come in and say, hey, show me all the errors that are happening for last 15 minutes. So I get all of this literally, I mean, this is a really tiny set of log data that we are getting. Let me show you how much log we are getting right now. We are getting about 157,000 log messages in this account in last 60 minutes. If I switch to our production account and looked at that, we generate about 60 million lines per second. So that's about, if I can do the math quickly on my head, it's about 4,000 times more log data. So when I look for errors in there, so instead of getting 19 in 15 minutes, I'm probably going to get 80,000 messages. So let me span the time a little bit and say how many errors have I gotten in last 60 minutes. So I see a few more. I can start seeing that some of the errors look very similar, right? And I would want to figure out, for example, show me which are the hosts that are sending the data, or show me the category by which errors are happening. So this is just something that we have had available for a very long time. And here I can see, these are app/db is the one that's generating the most amount of errors. I quickly, for example, visualize it as a pie chart. And I can say, if I want to turn this into a real-time monitor, all I have to say is add it to a dashboard. Give the dashboard a name, give this monitor a name, and you can generate dashboards that look like this. This is a quick background for some of the users who might be new to Sumo Logic. And when I put that pie chart in here, the difference between the searches, I have to manually go do the search, but once I turn it into a dashboard, this is powered by a continuous query in the background. So the UI pulls for new data every 15 seconds, and as more data gets into the system, you can see a little spinner on some of these, and some of the charts update. Every 15 seconds, it gets updated with a new thing. So I'm looking for the error distribution, and I want to see a spike in that error. This is a perfect way to look for those. But I'm still looking at things that I know I want to ask the question. For example, in this case, I know I'm looking for errors and a spike number of errors that I get, right? So that's one of the problems. Is how do I find out something that I didn't even know? There can be a number of questions I could be tracking, number of metrics I could be tracking is literally infinite. So where do I begin to look for the unknown things? The other part of the problem is there is too much of log data that we are getting. So, for example, if I'm just looking for everything that I have gotten in last 60 minutes, what you will start seeing is this is all the data that this demo application is generating, that we are capturing and feeding into the system. And as we can see in last 45 minutes or so, it had generated about 100,000 messages. That's a lot of messages. Even if I look for a small window, the number of messages that I get back today is a whole lot more. It will take me a lot of time to try to understand, let's say, these 40,000 messages. And so what we did provide this log reduce button. And the way the log reduce button works is it summarizes all of this data for you. So runs this, automatically starts figuring out what are the signatures. And so I'll pause it right now and explain what it is doing. So it's figured out that a lot of logs look like this. And parts that are in a star are the paths that change. So it kind of takes a guess at how the printf statement would look like. And there are 2,500 of these. I kind of come down to the page. I can see some more of these. And I have boiled it down literally into a few pages of results. And I can dive into any one of these if I'm interested in that. But if I looked at this data for 15 minutes before that, the summary of the logs is going to look very similar. So a lot of people, a lot of customers have asked us in the last 12 months is, we can summarize and reduce by 1,000x, by 100,000x the volume of log data. Can you further compare the two summaries and tell us what is the thing that changed between 15 minutes before now and in the last 15 minutes. That's essentially what anomaly detection does. A summary is like a baseline, and what anomaly detection does is it compares the baseline for the last 5 minutes or the summary for the last 5 minutes with the baseline that it has built over a much longer period of time. So this is our anomaly dashboard, what we call anomaly dashboard. So let me point out different things in there. At the top is a summary of all the anomaly detection reports that we are running. In here, you can see there are 5 or 6 individual anomaly reports that we are running. How do you create a new report? It's really simple. I mean, all you have to do is give it a name and optionally some filter to kind of restrict or focus on a certain subset of data, maybe all the firewall data, maybe all your application data, and so on, and let the anomaly detection run. Once it runs for some time, you start seeing these events on a timeline. So we're showing a timeline of last 6 hours, and you can see these events, they're all color-coded. And what colors mean, in my mind, the most interesting ones are the ones that are labeled blue, because those are the events that are yet unknown. We don't know, the system does not know what that event means. The other ones are the events that were unknown at some point of time, but someone has gone into those and looked at those and said, why is an anomaly? What's going on here? So, for example, let me look at systems time view here. There's one unknown event happened at 6:10 a.m. I come in here and take a look at why is this an anomaly, right? And so the way we try to present that anomaly by giving an anomaly is made up of several types of logs. They vary in several different types of logs. So, for example, the first log over here went down a bit. The second log entry went up by 5,000% in the 5-minute window, depending on what's expected here. We assign those an anomaly score, right? So the first one is a much higher score, the second one is a little bit less, and then it quickly becomes a diminishing thing. So the top few logs are the main contributors to why it's an anomaly, and if I'm looking at this, it's very clear to me that we are seeing a whole lot of SSH authentication failures in this 5 minutes, what is expected. Now, the part is, I do not have to look for this. I do not have to specify anywhere that I'm looking for a spike in authentication failures. The system has been looking at all data it's getting and the baseline and says, yes, authentication failures do happen, but not 30 times in 5 minutes. And if it happens, that's an anomaly. And some come in here and say, too many authentication failures. And this is really suspicious, and I may come in and give a medium priority. In this case, it's pretty self-evident, but if it was something that, something generated by ESX server, and it has a special meaning, we saw a case where a lot of logs that did not look like the root cause issue, but after doing some investigation, we figured out the root cause is not what appears to be from the log line. We can add all of that knowledge into the description, and once you save that, what happens, you get one of these log lines where it says, okay, we have seen one before. So the form it will show up as a blue, indicating that it's an unknown anomaly. Once someone looked at it and said, why did the login failure go up, almost doubled up in that time period, and that's a login failure event. Now the system it knows about what the signature looks like. If the login failed appears in there, it's a login failure event. And whenever that event happens again, it does a full matching and highlights that to you. So that is the workflow that we have. So this is a dashboard where you can come in. So you can go to the dashboards where you are looking for things that you already know about. You're looking for a spike in errors every hour. Okay, that's great. You go to the dashboard, you look at the dashboard. If you see a spike, great. You could the anomalies dashboard when you're looking for things that you are not even looking for, right? So these are the new things that the system mines out of your data and presents it to you, and you can see the known events, and you can also see the unknown events. You can analyze the unknown events and turn them into known events with appropriate names and severity and description and so on. So you are starting to build a knowledge base about your own IT data within your own company. And if you do this, other people in the company, maybe someone is on PagerDuty 2 in the morning and then see an event, and they can quickly know that the analyst before them has already annotated. Maybe there is a link to a wiki page or a web page where the remediation steps are there. And so it can become a very effective tool in staying on top of IT data as it continues to change. And I think this is a pretty powerful tool and pretty novel tool. We have seen some experiments, some projects, some features like this before, but something that works well at today's log volume scale and in real time is pretty novel.
Well, thank you very much, Kumar, and appreciate your walking through anomaly detection for the people in the audience and on the phone. We have a lot of questions that have come in. So I'm going to, just as a reminder, people can use the window in the Q&A box to ask questions, and I've got some questions via the chat window as well. So I will go through these questions with Kumar, and we'll start talking about them. So let's first quickly go through the detection itself, and so the idea of the baseline. So one of the questions, Kumar, was how long do you have to collect data for a useful baseline to emerge? And then I have a follow-up question to that.
Right. So I think that is a parameter that in the beta phase we have set it to 6 hours. So typically, if folks want to sign on for the beta program, we turn the night before, then we hop on the phone call with them, and we can start seeing events in the morning. But sometimes if you want to observe shorter trends, and if you are impatient, you might want that to be an hour as opposed to 6 hours. That is one of the things that we are working on. That is still in beta, and we are continuing to enhance the functionality. And so one thing that several people have suggested is an interactive way to set that time period. Sometimes you want to compare, just go after last 3 hours, and how does my last hour compare my last 10 minutes compared to that? But it really depends. I think 6 hours to 24 hours is the median where you can see a lot of interesting anomalies, and it's long enough that you can build a baseline, and it's not that long that you don't have to wait for a week before you start seeing any results. Till you leave it running overnight and come in the morning, and you will start seeing some new events that you can dive in.
Okay. And how do people account for seasonality? And if you're a retail store and you've got weekly seasonality and things like that, are there things that we're thinking about building into the anomaly detection sort of engine to take that into account?
Yeah, I mean, I can say 3 things about that, right? So one I would say is that is a really good feedback, something that we have gotten quite consistently in the beta program. And one way to do, and that works in many cases, is to label those events as low priority. Number 2 is it might be low priority on a Monday morning, but it's not a low priority on a Thursday if it happens on a Thursday. So for those cases, what we're planning to build on is every time we detect an anomaly, we'll generate an internal event. What you can do is you can do a schedule alert and say, normally it's a low priority event, but if you see this on a Thursday, send me an alert. So you can use that internal event and the rest of the scheduled search machinery to implement more fine-grained logic around that. A few people have asked for APIs to provide exceptions, because when you are pushing a new code branch to production or some application, the logs are invariably going to look very different. And what people have asked for is to effectively mute one of the anomaly reports for maybe an hour or so and then turn it back on. So those are all really good feedback and really good angles where we are planning to enhance the current functionality into.
Yeah. So we had a lot of questions come in about the percentages that people saw when they were looking, the delta essentially between what is expected in the pattern and what we saw in the pattern. And so the questions are really around, how that percentage calculated, right? And what goes into it.
Right.
And of course, I think there were a lot of questions around, well, I've got an event that scored high. I don't have a positive percentage of 30, whereas an event that has a positive percentage of 3,000 is scored lower. Can you talk a little bit about, without going into too much detail, about how that's calculated and what goes into it at a high level?
So without getting into the mathematical nitty-gritties of it, what is actually happening that we try to calculate the distribution of log data. And by distribution, we mean, how much variance is in different kind of log data and so on. Sometimes, if you're running a cron job every 15 minutes, there might be a lot of variance in a certain kind of log data. On the other hand, there might be certain type of log entries that are very steady, right? So we figure out, okay, log data, this type changes quite frequently, this type does not change that much, and then we factor that when we compare it with last 5 minutes. For example, if we notice a big deviation, but that type of log is known to be much more erratic or much more variance in the event rate of the data, that will get, even though the change is very large, but because it typically changes a lot, it will be considered a less important a factor in that event. And that's why you see some cases where the actual change grew 50x over last 5 minutes, but over last six hours, several times it has gone up 50x, right? And maybe it's normal. At the top of the hour, it always goes up 50x. So it's not that big a factor. But there is some very steady. You typically don't get 50 login failures in a minute or 5 minutes. And if you notice that, and it only went up, maybe you had 10, and you almost always are in the range of 10 to 12, but suddenly you get 50, and it's only 5x increase, yet it will score pretty high on that, right? So those factors come into play as well.
Great. Another question that came up is, if a critical anomaly incident, can you notify via script or an email out to either directly to the user or to a third-party monitoring tool?
That's the number one enhancement request that we have gotten, and we heard the message loud and clear, and the fact that it's coming up on this webinar is also pretty strong validation of that. The answer is, right now in beta, no, but before go GA, yes, absolutely. So that's, I talked about this a little bit earlier, is that we'll generate internal events, and the ability to do all those things is send an email, maybe run a script in response to that. We can do all of that based on those internal events whenever an event is detected.
Okay, right. We have a question that came up around log reduce, which is whether log reduce is more than counting of similar types.
It's one of those things that that seems pretty simple, and we have tried to make it pretty simple. It's a real problem when the log data has so much variety, and the variety keeps changing as we go along. But the idea is, how do you figure out what's similar? And what's similar, the litmus test for us is, will a human being think that the logs are similar? And over the last 12 months, what I've seen is, more often than not, it comes pretty darn close. And so anomaly detection, log reduce is primarily about continuing to look at the data and trying to refine. It never sees the source code, so it doesn't know for sure that the signature is the same as the printf statement. But as it sees more and more data, it adapts, and its confidence in those signatures increases over time. And the signatures also morph over time. So it's a pretty hard problem, but the result, as we wanted it to be, is actually pretty simple. Is map log line and guess its signature. And the key part is how accurately or how closely can you guess that signature.
Do you have any sense of, and obviously we're in beta, so this is, we're still sort of in the discovery phase of this, what the false positive rate during the human review is when you're looking at an unknown event and the determination of whether it's relevant or not to your business? Do we have any preconceived ideas of what that would be, or is that you buy customer?
Changes quite a bit, right? And it is a little bit of a factor of, if you have data sources that are able to determine the signature with high accuracy, and the number changes over time, right? So the first run that you do, you might see a lot of false positives because our system does not yet understand the signatures very, very well, right? And as time goes by, as the system sees more data, it has better and better idea of what real signatures like. And false positive rate itself is obviously dependent on different kind of sources, but it also kind of changes over time. And factor is, on the log reduce side, what we have built is the ability for users to edit the signature. And that is something that is a fundamental building block for anomaly detection. And what we are working as we speak on is the ability to access the same functionality from an anomaly detection page. So more often than not, the false positives are because there may be two signatures that are the same signature, but the system has not seen enough data to call it as such. A human user, when it looks at two signatures, can spot that right away. And what we are building right now is the ability to provide that kind of feedback. So this is a system that, with a little bit of assistance, can actually improve tremendously. And I've seen, for several accounts that to be the case.
And we had a question that came in that said, if you wanted to use Sumo Logic to replace a traditional log management SIM product, does it support standard compliance type reporting? By that I assume PCI and other types, like some failed logins, or is this something the end user will need to manually program in? And you can take a shot at this.
Yeah, no, absolutely. I mean, that's a really good question. We have been working a lot on, and I think Sanjay will have a lot more details than I do, but PCI, for example, he mentioned that we have been working on a lot of content. It's available for our end users. So a lot of this stuff out of the box. Operating systems, if you're looking to analyze Linux logs, Apache logs, Windows logs, a lot of content is available out of the box. A lot of applications are available out of the box. And if you like adding your own set of rules, I mean, the solution does provide for that as well.
Yeah, just to augment what Kumar said. So in addition to obviously the report and dashboards and applications by source type, we were also building specific compliance applications that by definition cut across multiple data sources. And so that's something that our team, both engineering and in product management, in our sales group, are building out, and obviously will be made available to the broader community. So absolutely something that we're focused on right now. And we can, if you have questions about, if you have a specific interest in mind, just drop us a line and let us know, and we'll be happy to get back to you.
Yeah. For example, I mean, we have a ton of dashboards and searches, and that is something that I have already seen work at a few customers. And so there's a ton of useful content in that app if that's something you're interested in.
Great. There are, I guess there's one question that came in early on that came in early on related to, so you remember the 2x2 graph you showed, reactive, proactive, known, unknown. One of the questions was, do you have a sense of sort of resolution time by box? And once again, I realize that that's a very broad, it can be very broad, but do you have a sense maybe of the order of magnitude difference in terms of how long it takes you to resolve things when you don't know something exists?
Right.
And if you didn't have a solution like anomaly detection versus, say, something like a dashboard or report versus a script.
Right. It's sometimes one of our customers, and they're a large customer, they have a lot of customers and users. Their system outage, and they're first trying to kind of troubleshoot comparing different nodes that we're running, and it have taken them typically maybe a couple of days to actually figure out exactly what was different. Would have required 4 or 5 analysts to work on it and kind of to find the root cause. And what they did was for trying to use the log reduce, and they were not on the beta program, and they log reduce and manually compared log reduce instances. One when they knew they didn't have that incident, and another one when they knew they had the incident. And by one of their analysts was able to figure out, hey, why are we getting so many of these different kind of logs in there? And that was a very important lead. I mean, I really look at anomalies as leads into an investigation, and more often than not, if you are on the right path, you can get to the real root cause 5 times, 10 times faster than if you have any leads at all. And you're basically trying to look at all the data, and if you have a lot of data, that can become a very cumbersome process. So that's anomaly detection, if they were on the beta, that's what the system would have highlighted. Like, hey, right about the time you were noticing these issues, there are these events that happen that don't look normal. And that becomes, it saves a lot of fishing time, and you can start right from there and dig into that.
Great. And then I think we have time for one more question here before we come up to the top of the hour. So does our product support a service provider model? And I'll go ahead and answer this. And the answer is yes, we do. In fact, we have a number of service providers who are customers of ours who obviously use Sumo Logic as a way of mentoring and managing not only their own internal systems, but also their customer systems as well. And that's, we've done a number of things to support that service provider type of model. We'll continue to do so. So I think it's, we found a number, both customers and prospects who are very interested in that. And the questions keep coming in. So I'll have one more, and as I said, if you have more questions, don't hesitate to drop me a line. Email sanjay@sumologic.com, and I'll be happy to try and forward those along to the appropriate person. But let's take this as the last question here, which is, does anomaly detection look into the variance of data coming in from different sources and detect if, for example, some source suddenly stops ingesting data, kind of acting as sort of a self-monitoring system? Yeah.
That's a really good question, and we have heard it a couple of times before, and that would be in the first phase after we go GA with the first set of functionality. So in short, that's a really good enhancement. There's no reason that the underlying tech cannot do that very easily. But I have to say is that there are a couple of other enhancements that we're much more often, and so get to those by GA. And this one I'm pretty sure will make its way into the first. We code every week, every few weeks. There is a major chunk of functionality that goes in. So I'd be very surprised if in a month or two after the GA, we don't already have this in the product.
I just want to thank, obviously, everybody for taking the time to be with us today. As I mentioned, we have recorded this and we'll be posting the recording to our website and sending you emails when that recording is done. And if you have any questions, don't hesitate to reach out to us. We'd obviously love to answer any further questions you might have. Thanks, Kumar.
Thanks a lot.